Welcome to Node.js Fundamentals by StrongLoop. What is Node.js? Let's see how Node's website describes the technology. Node.js is a platform built on Chrome's JavaScript runtime for easily building fast, scalable network applications. Node.js uses an event-driven, non-blocking I/O model that makes it lightweight and efficient, and it's perfect for data-intensive, real-time applications that run across distributed devices. Now, for those unfamiliar with Node, this description may be a lot to grok. So in the next 15 minutes, we'll cover the various features and benefits of Node in order to gain a super clear picture of just why Node is one of the hottest technologies in web and mobile development. Node allows developers the ability to write server-side applications in JavaScript, exactly the same way that a programmer might use PHP, Java, .NET, Ruby, or Python to write code for the server. In the world of web applications, servers typically handle things like writing data to the database, reading files from the hard drive, or connecting to other networks via web APIs. These activities are typically grouped under the banner of I/O, input-output. The JavaScript language was chosen because it is a nimble and relatively lightweight one, and the syntax is already well known to client-side developers. Previously, languages like C or Java used a synchronous I/O, which meant time wasted waiting. To reclaim this lost time, threads were added, but the complexity of multi-threaded programming is daunting. Though server-side JavaScript isn't new, Node.js avoids the mistakes of previous incarnations, and with its single-threaded module and design with asynchronous I/O in mind, Node.js is fast. Node.js uses an evented, non-blocking I/O. Let's use an analogy to compare blocking and non-blocking to everyday life events. You walk into a restaurant and take a seat. At the next table over is a party of 10 who've been there for a while and already ordered. You order a hamburger. Meanwhile, other people are being seated, other waiters are continuing to take other orders and deliver other food to other patrons. In short, this is an asynchronous or non-blocking model of functioning. Generally speaking, no one at the restaurant is blocking anyone else from doing work. Case in point, you get your hamburger before the larger party. Your request is smaller, and it doesn't need to come out at the same time as 9 other people. Now imagine a synchronous or blocking model of running a restaurant. You enter the restaurant behind 5 other people in line, but before you can be seated, the first patron must be seated. There are drinks and food served, and they have to sign the check and then leave. Then the second person in line is seated, leaving you more hungry than happy, right? On more technical terms, the traditional model of, say, serving HTTP requests from an Apache server means an entire restaurant must be spawned for every patron. How efficient is that? Terribly inefficient. You can very quickly run out of real estate or RAM. In programming, blocking is often defined as waiting for the result of an operation prior to continuing the program. In pseudocode, it might take a form like this for dynamically displaying someone's name. Download the people data from here. Once that's done, decode it for the person's name, then print. While the function download URL reaches out to the web to download the data people/1 JSON, the program is completely blocked. This has always been the most common way to handle downloading data on a server, but the same code would be written in Node.js as follows. Get this info from this function. If that info exists and has been parsed, then log it to the console. Now here's the good news. While this style of programming may look a little confusing when applied to a server, many programmers are already writing code this way on the browser. And for programmers with exposure to writing JavaScript in web browsers, particularly using jQuery, it will look something like this. Node.js allows us to use a browser-style concurrency model on a server, allowing for event loops. And this is quite a different approach from other programming languages like C or Java. JavaScript relies heavily on events and callbacks, allowing for an always-on experience. Simply put, JavaScript often waits for an event, and whenever that event happens, a callback function happens. Let's use the postman example to help this make sense. To our event loop postman, each letter is an event. He has a stack of events to deliver an order. For each event or letter that the postman has, he walks the route to deliver the letter. The route is the callback function assigned to that event, or sometimes more than one. However, critically, since our mailman only has a single set of legs, he can only walk a single code path at once. Sometimes, while the postman is walking a code route, someone will give him another letter. This is because the callback function he is code walking has emitted an event. In this case, the postman delivers the new message immediately. After all, someone gave it to him directly instead of going via the post office, so it must be urgent. The postman will diverge from his current code path and walk the code path to deliver the new event. He then carries on walking the original event that emitted the event he just walked. JavaScript was initially designed for the web browser, and the event loop model serves the browser very well. Consider listening for mouse events inside the web browser using jQuery. This code will do nothing until the A element is clicked. But what happens when the click event fires? The browser will alert with the message clicked. This is the event loop in action. All web browsers are continually looping, looking to see if events have fired, and when they do, any callbacks will be fired. The power may not be instantly obvious with our simple click example, but the event loop is extremely powerful. Instead of blocking entire programs waiting for I/O to complete, a mouse click is a form of input, the event loop allows applications to move on and wait for events in order to continue the flow of the program. Revisiting the initial definition of Node might be a bit clearer now. Node.js is a platform built on Chrome's JavaScript runtime for easily building fast, scalable network applications. Node.js uses an event-driven, non-blocking I/O model that makes it lightweight and efficient, perfect for building data-intensive real-time applications that run across distributed devices. With Node, developers are able to write server-side JavaScript to handle things like database connections that connect to web APIs and build powerful websites. Each program or app can be thought of as a node in a larger network and can be called by other nodes running in other parts of the network. This allows for easy reuse and rapid evolution of code, and that in turn creates an appetizing climate for developers. Why Node.js? Well, it's popular. It's growing fast. Lots of big brands are using it. It's well supported. It's one of the top 4 languages spoken in the cloud. Maybe that's why you're here. Now that you know that Node.js uses an event-driven, non-blocking I/O model to provide developers with an environment to write scalable and efficient network programs in server-side JavaScript, here's a little secret though. Node isn't alone. Virtually every popular programming language offers a nearly identical environment. For Ruby, there's EventMachine. For Python, there's Twisted and Tornado. Java has VertX and Akka. C has epoll, KQ, libevent, libev, libov. Perl has Perl Object Environment. The list goes on. So if most programming languages can do what Node does, why is Node so special? The Node.js community is the reason for its success. Now, the community began with non-blocking, event-driven I/O as its programming model. That means successful libraries will be written from the beginning as asynchronous, non-blocking code, and this is significant compared with event-driven frameworks in other common programming languages, which are rooted in a blocking model, and then might optionally provide a non-blocking alternative. Because Node.js is the new kid on the block, and because it is in JavaScript, commonly used for event detection in a browser, it is rarely used in a blocking fashion. The net effect is that Node.js modules are built to support high-performance networking applications. The Node.js community doesn't just rally around the asynchronous nature of the JavaScript environment. Node's philosophy around the development is to keep Node core as small as possible and allow for userland to be the driving force for incredible features and progress. This means that the network effect within the Node community is exploding, and NPM, the Node package manager, is quickly becoming the largest source of open source libraries available in the world. Node.js is perfectly positioned as the technology to power mobile applications, which often rely on many services tied together. Node is exceptional at providing the API glue to power mobile applications. Its non-blocking I/O model, combined with JavaScript, make it great for wrapping data sources such as databases or web services and exposing them via a JSON interface. That's why companies like LinkedIn, Microsoft, and eBay are already using Node.js to efficiently and effectively power their mobile services. Streaming data or real-time information is served efficiently off of Node servers and into mobile devices. Use cases where data models have the same needs across the client and server are very well suited for Node. These are the types of challenges Node.js handles exceptionally well. Plus, if you happen to have the next viral app, you need to be able to exponentially dish out responses to all those requests without hanging up the server. Want to make an Ajax-heavy single-page app? Node.js was originally created as part of the effort to make Gmail, and it has only improved since then. The ability to process many requests with low response times, as well as sharing things like validation code between client and server, make it a great choice for modern web applications that do lots of processing on the client. Node.js can also spawn child processes in Unix, and then treat those outputs as a stream, making it ideal for those looking to leverage existing software. What's next with Node.js? Your participation. Node.js is easy to learn, and in our next module we'll show you how Node works, then let you dig in and get your hands dirty with some code. There is already a vibrant community of Node.js developers working on the next generation of web and mobile apps, but there is still plenty of room for you to join in and make a difference. With as much support as there is for Node, the environment remains impressively dynamic and evolving. Node provides programmers with a thriving, modern community that is unmatched in the space. Are you interested? Then join the Node Republic and become a part of the Node movement.